This is Espen Järvidalo and Alexander Pchilintsev, and today we're going to talk about how we integrated Vaadin and Google Web Toolkit into content management. So the talk will be devoted to the administration interface designed for the latest version of Magnolia CMS and actually the framework that is built around it. But let us briefly introduce ourselves to you first. So, as I said, my name is Alexander Pchilintsev, and I first actually touched Google Web Toolkit in a more or less serious project back in 2008. In 2010, I found out about Vaadin and actually worked with the technology ever since. And in 2012, I joined Magnolia development team to work on the 5th version of the system, and that is actually powered with Vaadin and GWT.
Okay, so my name is Espen Järvidalo. I started at Magnolia in 2011. My first project there was to re-implement our old JavaScript-based VCV page editor with Google Web Toolkit. So this was also the first time I came in touch with GWT. After that project, we jumped right into the Magnolia 5 UI implementation, also using Google Web Toolkit, but also heavily based on Vaadin. So Magnolia International is a Basel-based company. It was founded in 2003, so we had our 10th anniversary this year. By now, we are reaching around 60 employees worldwide, and 35 of those are situated in Basel. The rest of our guys are spread around the globe. So we have offices in Czech Republic, in Spain, and two newest ones are in Miami and Beijing. So here you have a selection of customers who use Magnolia CMS. To give you a little idea of what kind of magnitude in terms of scalability and traffic Magnolia CMS is dealing with, let's have a short look at Al Arabiya use case. It's a news channel broadcaster situated in Dubai, and it's broadcasting in the Middle East and North Africa. They have 40 editors publishing 24/7, and the result of this are 200 new articles a day, and an overall of 160 pages they manage in Magnolia CMS. They also hit traffic peaks of 20,000 visitors per second. So to deal with such requirements on scalability and durability, we are using the best of breed OpenStack. So it's Java based, we are running Apache Jackrabbit, implementation of JCR on the persistency layer, and of course Google Web Toolkit and Vaadin for the administration part. Magnolia CMS has been designed for customization and extensibility from the beginning, and we are open source. So this is not really putting us apart from other vendors, so what makes Magnolia CMS special? Magnolia CMS is attractive. So editing content is not the greatest pleasure I can think of, but the worst thing is that content management systems usually make it even more frustrating by providing a horrible user experience. So in the next minutes, we hope to prove to you that it's actually possible to make content management enjoyable.
So, let us explore what is hiding behind this login screen that you see. So, meet Magnolia CMS Admin Central interface. It's the administration UI of Magnolia 5. From the technical point of view, it's a normal, well-known Vaadin application, even though it might not look like a regular one. But the structure of Admin Central resembles the one that you have in your tablets and smartphones. It is all about the apps after all. So you can see 3 icons in the top that actually reference the so-called system apps that are always there, and they're just helpers. And the first one of these system apps is right in front of your eyes. It's called the App Launcher. It provides the access to actual user apps that manage your content. So, what's going on? Okay. So the second system app that you see is called Pulse, and it aggregates the inbox messages, allowing Magnolia CMS users for communicating with each other. And the third one is called Favorites, and it keeps the bookmarks to the various parts of Admin Central, saving some users' time on navigation. However, let's get back to the apps launcher and actually explore some user apps. We can examine them on a real-life example of a typical task that Magnolia author might face. So what we're going to do is we want to mention GWT.create conference in a page of website that we're responsible for. So the first thing we have to do is, for instance, to import some kind of a resource into our CMS that would be related to the conference. And so we open up the Assets app, which is responsible for handling all the resources of the system. And let's quickly take a look at it. So it gives us the tree view of all the resources that are currently imported in the form of Vaadin table, structured in folders. We can actually preview the assets, and on the sidebar we have the actions that are actually available for assets. So in order to import our shiny new asset that's related to GWT.create, we've prepared a folder and we fire a corresponding action that gives us a form of a new asset. We drag a file, we upload it, and it's there. Then we customize some of its properties, just set the caption, and then we save it. It appears imported into assets workspace of JCR. So we can see that it's there, but we kind of think that it's too wide probably, and we want to crop the asset a bit. So we start the media editor tool, and we then just crop it. And the asset is updated. So we have a picture that's related to GWT.create, and now we want to actually put it into a page of our website. So for that, we go to Pages app. So the browsing of pages somewhat looks like an asset. So we also have a tree of pages of our website, and they're also structured with Vaadin components, and we also can fire actions on them, and we find the page that we want to modify, and then we start the visual editor that manages pages. We make it a bit wider so we can see all the areas, and here you can see the annotated areas of the page that we can edit. We select the one that we want to modify and substitute the picture that's already there with our new one. And it's there. So basically the page is modified, we just preview, so to see that it actually looks good in the browser. And yeah, everything's fine, so this task is accomplished, and we can proceed with other tasks. So this is just a typical action that the user of Magnolia CMS can do. However, of course, Admin Central is not just about that. It provides access to configuration of CMS, allows to tweak it and to change it, gives information. So, for instance, just we have an app that provides us with the installation information. Or if, for instance, you are confident with programming or just old school, we have this shiny Groovy console that allows you to actually work with CMS on the low level with Groovy language. And here we just simply access the asset node that we've imported recently and just play with its properties. And all this integration is done also with Vaadin. Actually, this is an example of Vaadin and JavaScript API. And this is what Admin Central is pretty much all about. In the scope of this presentation, we're not talking about the final goal of any CMS, the website. We're concentrating on actually the apps and the environment that's prepared for apps, which is a so-called Magnolia Shell component. So these are our emphasis, whereas the websites are not covered in this session. Okay.
So what you just saw is the current state of Magnolia CMS, but we would like to recap at this stage and give you an idea of the journey from the first ideas to the actual implementation, including some of the bigger challenges we met along the way. So let's start the journey in 2010 by peeking at our old admin interface. So while Magnolia's code base has grown over the last 10 years, the UI has more or less stayed the same. So apart from the obvious, well, it kind of reminds of the year 2003, some other reason why a refreshment was needed. It was very hard to extend and customize. There were times when every new browser version called for updates on the JavaScript implementation of, for example, the tree view you see here. And when we talk about touch support, it was conceptually and implementation-wise simply not possible. So on the one hand, it was clear that we needed something new. On the other hand, just throwing in a new technology stack would have annoyed heavy users because after all, that thing has been improved over years. And while at it, it should probably look a bit more like modern web applications. So first we started off with design proposals. This is one of the later ones where you actually see the app concept kind of coming through on the left side. Still, it's very close to what we already had. Meanwhile, the development team was evaluating different technologies to craft this project we were starting, and width-based frameworks soon made the race, because after all, we are a Java-oriented company, and we also like to program Java, obviously. So why we ended up choosing Vaadin in the first place. So Vaadin has a rich collection of components. It's well documented, and on the service side, it's easy to do pure JUnit testing. And the reason why we stay away from a solely grid-based solution is that our users need to customize the Magnolia-based application without having to recompile the widget set or even know what the widget set is. So still to really make sure that Vaadin would fit our needs, we made a prototyping sprint where we concentrated on some of the trickier parts of our requirements. And in 3 weeks the team put together a working prototype. So just in 3 weeks we had something where you actually could hook Magnolia underneath it, and you had a tree view. I mean, it's not really looking good, but it was a functioning prototype at this stage. And you were also able to launch the page editor, which also was a bit shaky, but the concept was working already after 3 weeks. So at this stage, everything was set for development. We had some design proposals, and we also had the technology session in place, but instead we decided to throw everything away except for the decision to go with Vaadin. And the reason for that was that we saw a bigger potential in Magnolia together with Vaadin, and just replicating the old user experience was not something we wanted to do. And we also wanted to explore what we could actually achieve when it comes to touch devices. Okay, so we went back to the drawing board and we started developing clickable user experience prototypes. And over the whole process, we actually had 3,000 of such mock-ups developed and also discussed. So we started evaluating also new design proposals, and we also developed a sole JavaScript mock-up, just to make sure that the whole thing we wanted to do with transitions, click, and all that stuff was actually doable in the browser. So finally in mid-2012 we started developing, and almost precisely 1 year later we released Magnolia 5 as you've seen it now. Now you know how the journey started and how it ended, but we haven't talked about challenges we had to overcome during that time. So when we talk about challenges, we want to divide it into conceptual challenges and technical challenges we as developers had to overcome during the project. When you talk about conceptual challenges, it's in a broader sense, so it's more about what challenges do you have to overcome when you provide a CMS for people. So one of the reasons is, for example, that people decide not to go with a CMS and rather develop their own engine because of the lack of freedom, so they end up fighting the system and fail to adapt the CMS to their problems. And Magnolia has always been a modular framework and put emphasis on making contributions and extensions easy to develop, but not in all aspects. So for example, we already talked about how hard it was to extend the old admin interface, and we did not want to end up in a similar situation. So when we started with Magnolia 5, we wanted a modern experience combined with a clear vision on how you could extend it. And we approached this conceptual challenge by breaking the UI into smaller, very task-oriented parts, and that's our apps in the end. So apart from this, we also had some complex technical challenges to tackle. So it should work nicely on touch devices, instant feedback on touches, gestures, transitions, lazy loading, and well, in the end, you should not have the feeling that you're dealing with a web application. It should feel like a native application for your iPad or whatever.
So, in order to prepare the foundation for app-driven user interface, we had to start with the design of a GUI shell that would actually manage their layout, navigate between apps, and provide also access to system apps. And, well, not thinking too much about the naming, we named the whole thing Magnolia Shell. And the idea of it was rather simple. So we have a viewport, and it should manage navigation by dispatching the navigation events done through address bar to the backend. However, the design team didn't want to make our lives easy, so they came up with a variety of transitions that we had to support to make Magnolia Shell smoother and provide better user experience, which you probably have seen in the demo. I at least hope so. And in addition, we wanted the same user interface to work good, really good on all the platforms. So it should be as convenient for tablet as for desktop. And of course, that would mean an extensive support of touch events and gestures. So we tried first to carve Magnolia Shell out of plain Vaadin 6 at that time and components and add-ons, but it didn't bring too much success just because it was kind of getting quite heavy and complex. But luckily, there were capabilities to just build it with client-side and client-side code, and we done it as a monolithic, completely custom component that manages two viewports within it. So the whole Magnolia Shell UI client-side was built with GWT DOM API, and all transitions between apps were implemented also 100% on the client side without notifying the server, just to save some round trips. And the actual lifecycle of an app management was still handled on the server side, and we've chosen the URL fragment handled as some kind of a protocol for it. So Magnolia Shell, on the one hand, listens to the browser history change events, and on the other, it performs transitions if any required and renders the apps in either viewports. So navigation system that we've chosen was significantly influenced by the so-called GWT's activity places framework. We have utilized its abstractions and ideas by porting it to server side and still maintaining the concept and the logic. As long as we were not aiming for the same level of abstraction like activity places, we have used the names that actually suits us better. But nevertheless, those of you who actually are familiar with activity places will quite easily grasp the idea of what Magnolia app is and how it works. Just because the app and its context are somewhat close relatives of what activity is, but of course powered with the server side of Vaadin and Magnolia services. And location objects that we use for navigation are conceptually very close to places. Of course, during the development and early testing, we had to face a variety of complications, and amongst the worst ones was the sluggishness of JavaScript transitions, especially for mobile platforms. We actually solved it in a bit a hacky way, but which saved us a lot of development time eventually. So we took the jQuery library with an animated enhanced plugin that would substitute the JavaScript animations with CSS3 transitions that are actually hardware accelerated, and we got an instant boost of transitions also on tablets, which pretty much solved all the quirks. So among other gotchas that we had to apply in the development of Magnolia Shell and Admin Central in the whole were, for instance, the use of MGWT framework for touch gestures and events, and we found it really convenient to combine with Vaadin and GWT components. We use standard CSS trickery to force heavy parts to be painted in a separate layer in the browser, just to increase rendering performance, also especially on touch devices. And what we found really a lifesaver at some point was the closure compiler, which was integrated with GWT 2.5, and it instantly reduced the compiled JavaScript size by a huge amount of kilobytes. Well, last but not the least, it seems like with all those Retina displays and different resolutions that we have nowadays, it seems like icon fonts is the only way to maintain crispy, sharp icons in your app, and we happily use it everywhere in Admin Central, and we don't have to kind of maintain different PNGs and whatnot. However, I give the word to Espen now.
Okay, so at this point we have the first big technical challenge solved. We have all the smooth transitions, giving instant feedback, lazy loading, and so on. We have a clear concept of how a user accesses and manages data using apps, but yet the conceptual challenge is not solved, how to extend the system. So the idea was to provide a solid UI framework which easily allows extending. But around February, 5 months before we were supposed to release Magnolia, we realized that our modules dependencies looked like this, and there's not really something you would like to dive in as a contributor. And the next technical challenge was to refine what is what.
Yeah, it's good.
Yeah, okay, everything fine. So we had to refine what is what, and also make sure that the correct patterns were used throughout the system. And this is what we were aiming for, so a layered architecture where the upper layers are depending on the lower ones, but not vice versa. And it's also something you as a developer would like to see. The result of this is our app framework. The app framework provides abstract classes and interfaces.
Jeez. Damn it.
Sorry. So yeah, the app framework provides abstract classes and interfaces, and that's also your point, your entry point to developing apps for Magnolia. So all you need to do is extend the right classes depending on the scope of your project. You have the so-called base classes, which give you the very minimal you need to get started. This is where you hook in for a simple Hello World app, for example, and from there on you're free to develop whatever you want inside your app. The Groovy app you saw in the demo, or in the video, it was a video by the way. The Groovy app we saw during the demo extends these classes. And And in case you want to have some kind of more data-oriented apps, also like we saw in the video, like the asset app, you would extend the content app classes, which will allow you to browse your data and also edit data samples. So what are apps from Magnolia's point of view? They are a simple UI component. They can, for example, be the visual representation of the module you want to contribute or to develop for Magnolia, for your project in Magnolia, sorry. But still, you can have multiple apps inside your module, so there's not a one-to-one relationship between apps and modules. And apps from Vaadin's point of view, they're kind of like sandboxed apps inside Magnolia's Vaadin application. And in the end, they're just a composition of components. So if you take the Hello World app, again, it would just be a one-liner consisting of a Vaadin label. So what can the app framework do for you? And what is it actually good for? So that's, for example, the life cycle of your apps, when you close and open and switch between them. All this is taken care of by the app framework, so you don't really have to care about it. But on the other side, you can hook into its life cycle. So when your app starts, you can implement own implementations on how to react. And we are, for example, using location objects, so we wrap the URL fragment from the browser inside a simple bean. An URL fragment looks like this. So you have the app name, the sub-app ID, which is essentially a tab inside your app, and your parameters. So this is the fragment, and the nice thing about it is it makes it bookmarkable, and you can also use the back and forth button of your browser. Back to the actual framework. So throughout the product, not only in the UI-related code we're talking about here, but throughout the project we use inversion of control, so the constructors declare what components they need. It's based on Juice. In Magnolia, the mappings between the interface and the actual implementation is configured via module descriptors, so that's essential XML configuration. We're also using custom scopes for our app framework. So you have an application-wide scope where you can communicate on the whole application scale, or you can use it on an app-based scope, or even inside a tab. So let's wrap up the essentials of this framework in a simple Hello World example. What you see here is an implementation of a tab inside an app. So we already said we call them sub-apps. It extends one of the base classes and declares its components through IOC. Notable when you look at the constructor of this snippet is the app scope of the event bus. So you inject an event bus, which is scoped on the whole app, into one tab, which essentially means you can communicate through the event bus from one tab to another. And you could reduce that scope to the actual tab, or you could widen it into the whole application. And you also see the view is also injected into the constructor. Okay. And here you then actually have the view implementation, and this is what it looks like. So it's in the end just a label stating Hello GWT.create, and that's it. That's essentially what you need to know if you want to write an own app inside Magnolia. So at this point we provide a framework with app lifecycle management, communication mechanisms together with IOC and data binding to JCR. But a CMS is still about content editing, and the majority of users are not skilled with Vaadin or even programming at all. still they need to adapt the system to their needs. So what can we do to make content management extendable for such users?
Okay, and the solution for this problem would be a content app. So, we already mentioned them briefly in the app framework overview, but content apps are a bit more just some classes that you can extend. So here we will cover most important and commonly used components that serve to accomplish two main tasks of content editing. So basically the convenient way of browsing the data and performing various operations on its samples. We will start with one of the two main components of content app. It's a so-called browser sub-app. It's responsible for showing the structured data to the user and for initiating the editing. The data is browsed in a workbench component, that's how we call it, and which is supplied by a custom Vaadin container that is connected with some of the workspaces of Java content repository that we use as a data source. It's a bit inspired by SQL container, because Java content repository supports SQL, and we use lazy loading mechanisms and deferring of changes to the containers, so basically it's capable of handling thousands of nodes, which is usually quite enough for content management. As long as JCR repository has a tree structure, it's rather convenient to display the data in a tree tabular form. For the case of the assets app that you see on the screen, we can observe the fragment of the dynamic asset management workspace displayed in a Vaadin tree table. However, the form of data representation may be different. So one browser sub-app is capable of showing several types of data display. For instance, Assets app supports small thumbnails view, and your app might support something completely different, like a graph view or whatever you could come up with. And actually, it wouldn't be that hard to implement. And the reason why is that under the hood, the workbench component, just like pretty much any other component, some of which we're going to cover later, is implemented as a set of subcomponents based on model view presenter pattern. And the view here is just a pure Vaadin view, like all Vaadin developers know it, just a composition of Vaadin components. And presenter is also it's just something that you can easily understand. It orchestrates the view and connects Vaadin to Magnolia services, for example, through IOC, and it's able to communicate with other parts of the admin central by means of an event bus. What is actually interesting in this is the model, because it's of course JCR repository, as we have discussed before, but the interesting part is that it's not only acts as a data source for the presenter and for the component, but it also comes as a configuration source for UI. So it's possible to plug or substitute the parts of UI by just changing JCR nodes. And one of the components that we can configure is, for instance, an action bar, which aggregates the controls that trigger actions to be performed on the selected data samples. Such actions include typical CRUD operations, as well as content-specific actions that make sense only for the data type of a current app. For instance, Assets app allows for editing the properties of the selected resource. And another example, which is quite important in Admin Central, is a form editor, which also can be configured. It's a foundation of a so-called detail sub-app, and the purpose of it is to be able to provide a convenient, comprehensive, and structured editor of an arbitrary JCR node type. However, you might want to ask, how does that help non-programmers extend in the system, because the users of Magnolia CMS might not know Vaadin or even Java? And the answer is that by means of automagical node-to-bean mappers, we're able to describe UI components within configuration tree and let Vaadin generate the views based on them. So the diagram you see explains in brief how it happens for the case of the form editor. So first of all, we have the nodes declared in JCR config workspace, and they have hierarchical structure, and then we map this small fragment of the tree to a definition object, which is later on consumed by actually MVP pattern, by the presenter, which passes it on to a chain of factors, builders, and eventually it is the Vaadin UI is generated on top of it. Well, considering the fact that actually configuration workspace is just another tree in the repository, we're actually able to work with it in a way like we act with other content, with content app. And what you actually end up with is that you configure your UI within the UI. And that's how we understand it.
Okay, so let's pick that up again. So you configure your UI inside your UI. I want to show you how that actually, what that actually means. So for that, we will open the Contact app. The Contact app is just a sample app we use. It's just a regular content app, and it's solely based on configuration, so there are no implementation classes involved with this simple app. And then we're going to showcase, give an idea of how that works. We'll do a very simple example. So here I have the form to edit a contact. It is built up by 2 tabs inside the form. So inside one tab you have fields. So you have, for example, the salutation, the first and the last name, and so on. Now we want to adapt this, and we want to kind of, for example, just add a Twitter account to that, which makes totally sense with Marilyn Monroe, but anyway, let's just do it. For that we open the configuration app. Sasha's already told you a bit about it, and this is how it looks. Again, it's a simple content app. Here you actually have a list of modules installed in the system, and here also your module will show up when you're developing against Magnolia. Here you have the contacts module. Here you see the first part of the configuration. We will concentrate on the apps inside of it. We have just one app. One app consists of different sub-apps. Those are the tabs. You have the browser, where you can browse the data, and the detail sub-app, we call it, where you can actually edit it. So let's jump into first the browser. You also see some of the components Sasha talked about. You have the workbench, the action bar, and so on. So look at the detail. We go into the editor, and here we have a form, as I mentioned before. We have a composition of tabs. We have the personal tab, the contact details tab, the fields, salutation, first name, last name, and so on. A file upload to change the image. Now let us put another field in here. We will just duplicate one of the simpler one for this case. So this is basically a text field, not very interesting, but you could also hook in validators here, so it gets complex. But for this case, we just take the easiest one. Maybe just add a caption to it. And now we will go back into the contacts app. But first reorder the nodes. That comes at first place when we start the app. Go back into the contacts app. Go back into Marilyn Monroe, and here we now have the Twitter field. So the idea of this video is just give you an idea of how it actually works. This field example is pretty simple and stupid in the end, but I think the essential idea of what we're showing here is that you can actually create your app just by configuring it. So we had a short look at how it looks like in the tree, And you can copy it, you can modify it, you can export it, and so on. And that's the key message. For extending Magnolia, you don't need to program. You can just work with the configuration tree. And I think at this stage, we have the technical challenge solved. You saw some of the APIs. In my opinion, I think they're very clean, and it's very clear how to extend it, but I hope some of you guys will actually try it and give feedback on it. The conceptual challenge is also solved, so you kind of saw how a non-programmer can also create this app, change its fields, and adapt the data it's working on. So at this stage...
Yeah, so basically what we want you to take away from this is that CMS can actually be pretty with the Vaadin's components and nice and lively look and feel. And with the right apps and convenient components, CMS can be also user-friendly. And finally, a simple and flexible framework CMS provides can make it friendly to developers. And that's our main message. So we actually have some iPads with us, so if you want, after the presentation, you can come and try it out on iPads or on desktop. And of course, we will gladly answer to your questions. And thanks for your attention. Yes?
Hi, it's Philip of Comlock. I have two questions. First question, it's my understanding that all the Vaadin integration you showed is only based in the admin interface, so it's not possible to develop apps that are directly shown to the user as part of a page inside the content management. That would be the first question. Second question, everything you showed here is available in the community edition, or is there any licensing needed, because you also provide commercial models, as I understand. Thanks.
I'll go. Okay. So basically, answering your first question, yes, that's correct. That for now, we're using Vaadin as an administration interface basis. Because Vaadin is stateful, at least it's kind of moving away from such a pattern, but still it's kind of hard to come up with an idea how to render the websites with just Vaadin or with. However, brave hearts are trying to actually craft something like that, and then hopefully in the future, when we have more development time, we'll research this area. Answering your second question, of course, it's all available. It's all open source. It's all in Git. It's all available for download, and there is a demo site.
Yes.
You can find it probably at our website. So yeah, it's referenced there. So yeah, I guess that this is yeah. Feel free to touch it. Anything else? Yes.
Is there a bridge to put in Portlets or some old world components?
Do you mean in admin interface?
In the CMS.
As far as I know, it's always a bit of a topic, and I think open social is one possibility to kind of get this portlet idea into it, but portlet API is not supported as is, and yeah. No, I don't want to go with my personal opinion here.
Well, however, we still have the so-called like embedded apps, which allow to integrate apps in the form of iframe. If you don't know how to come up with how to solve your problem with the framework that we provide with Vaadin, or you just don't want to do that, but you still want to use it in Magnolia, then you can just put in an iframe, and it's also kind of in the form of an app. Any more questions? We take it as a no. Well, thanks a lot. Thanks for coming. Thanks for your time.